For the final project, we decided to design and construct a rubber band gun. For the first week or so, we collaborated on how we wanted the gun to look and perform and made designs based off of that. We made goals for the final product to be able to shoot multiple rubber bands at once. Once we had a plan, we put the design into SolidWorks and played around with the dimensions and tolerances for the interconnecting parts. Once we had finalized those, we were ready to move drawing to the 3D printing stage.
Our group decided to use additive manufacturing for the following reasons. It's easy to use. It has a wide range of design options using CAD. It's free through Driftmeyer's Fab Labs. It has a quick turnaround time for physical prototypes, and it's safer to use than other manufacturing techniques. So as you can see, the 3D printer builds up the rubber band gun layer by layer, and each layer amounts to about 100 micrometers. We converted the SolidWorks file into an STL file, which stands for Standard Tessellation File, which allows us to communicate the file between the 3D printer. So as you can see through this video right here, the rubber band gun is being built up layer by layer. The actual time that it took for the rubber band gun to be constructed was about 1 hour. As you can see, this is the final product and all of its components. And as you can see, you have to actually pry the product off of the surface to get it off.
The first model suffered from various fitting problems. Tolerances between handle pins and the trigger and pinwheel were too tight, preventing assembly of the parts. We also determined that we wanted larger infill values for load-bearing parts for greater strength. So the main focus of the second design was to fix the tolerance issues and increase the infill percentage. The second design successfully solved the issues from the first. We were able to assemble the parts and had our first functioning prototype. However, there were still more problems we wanted to solve. Because of the trigger design, we were only able to shoot one rubber band at a time, and the gun was also uncomfortable to hold because of the slim main body.
Our final design solved two problems from our previous design. We added a reciprocating trigger to allow more than one band to be loaded and shot. We also added a reflected side of the handle to replace the previous cap that was difficult to secure in place. Here's a demonstration of our prototype operating. As you can see, it was able to hold more than one rubber band.
We were able to achieve both goals that we set for this project, which were to shoot a rubber band with the pull of a trigger and be able to load and shoot multiple rubber bands. The 3D printer helped us to achieve these goals because we were able to quickly redesign and print any parts that needed adjustment. This flexibility is what allowed us to refine the products to fit our original goals.
Our group followed a few safety precautions to ensure the safety of our members. One of the main safety precautions we followed was eye protection at all times in the Fab Lab facilities and while testing the gun. We also wore closed-toed shoes to protect ourselves against superheated plastics from the printers and from other debris in the Fab Lab facility. We also maintained social distancing with other teams. Thank you.